Thanks everyone for coming tonight. One of my first technical talks in quite a long time. I was hoping to do this a lot more recently, but COVID kind of stopped that up. So hopefully everything will go okay. Got a lot of gifts, so hopefully they work. So today I'm going to talk about taking Jetpack Compose animations to the next level. So if you're like me, you never get time to do animations. You always, you're under the pump, you've got some work you need to deliver for a client or deliver for your product owner, and you just don't have time to fiddle around with timings or work on all that minutiae that comes with animations. So you have to push it to the end, usually it gets dropped off, and you can't get that nice experience that users expect. So this is something I experience all the time. So I've never really done a lot of work with animations. It's just not something I've ever had much experience with. So recently, when I was between projects, I decided to have a go and try out a few different options and make some time for animations. So I did a bit of experimentation. So at that stage, I hadn't done much with Jetpack Compose at all. I'm still very new to it, so there may be a few errors in my code. But I experimented between different view-based and Jetpack Compose animations. Object Animator, Animator Set, Motion Layout, and the Jetpack Compose Animator APIs. You can see from here, some of them were better than others. There's one of those little things going off the screen. So, just a little context about what you're seeing. You may wonder why there were cards moving and what those weird cards look like. A bit of a confession, I'm a bit of a nerd and I like board games a lot. So in my spare time, I make apps that help out you play board games. I think that's peak nerd level right there. So if anybody's interested, come and talk to you later. Always love to talk about them. This app is a companion for a game called Welcome to the Moon. It involves flipping a lot of cards. Nobody's got time for that when they're into playing a game. So I've made an app that just does that card flipping for you. So if you've looked at Jetpack Compose animation, especially the official documentation, you may have seen this lovely flowchart. And if you look beneath that flowchart, there's a whole lot of text, and it's quite hard to work out what you need to use when. I know what they're trying to do. They're trying to make it easy for you to understand and to work out what you want to use, but there's a lot going on. My original plan for this talk was to show most or if not all of these to you as a comparison. When I started doing my deep dive, I discovered there's a lot there. So we're just going to focus on two of them. So the first one I'm going to focus on is target-based animation, giving fine control over your animation between two values. And also animated visibility, animating the appearance and the disappearance of elements. So for that first target-based animation, I'm going to show you flipping cards. So you can see from this GIF, you've got a card, and it flips over to show the back of the card. So how do we do this? So step one, we need a basic layout. All this code I'm showing you here, I've got some blog posts for this, so no need to take photos or anything of code. And it's all on my GitHub, so you can check that later. This is basically just the container for this. We have a stack of cards, we have a view model, that just will show you the top cards. We don't need to worry about what's beneath them. We only need to care about the actual active data we care about. So we have our action stack and our number stack, and we have our current card, the card that is going to be animated. We can pass this into our stack layout, which is what I'm going to talk about here. As you can see, I'm passing in composables. This way I can abstract all the actual UI of how those cards get displayed away from this and just focus on the animation. So this is our stack layout. This is the one I'm more concerned about for this talk. So we have our number stack, our action stack, and our card flipping. We pass those in. And then for my initial layout, I'm using a row. So this is just laying two cards next to each other. And then I have a box, which is containing our active card on top, just so it's laying on top of the other card. Pretty basic. There's zero animation here. As the data changes, this just comes through. No animation, no fun. So, how do I position these so I can do animation? I'm going to use a custom layout here. And a bit of a disclaimer, I also found that I could, after I had prepared this example, I found I could also do this with a box with constraints. But I've left this as a custom layout as it's a good example. So, there's a lot of things happening here. No need to understand all of it. What we have here is we have our custom layout. If you haven't used it before, it's broken into a few sections. So we first declare our layout composable. Then we put in our content. So our content here is not positioned in any way, and we've actually assigned an ID to each one of these, which you may remember from the view-based days. IDs are very powerful and useful. So here I just have my 2 stack composables displaying, and then my card, if it's present, I'm displaying it. We then collect those placeables. So we use a find command to find them using that ID, essentially like the find by ID back in the view days. It's a very low-level way of doing it. It is quite powerful if you are playing around with this component to collect lists of other components and place them relative to each other. It's quite cool, so I recommend playing around with it. So now I've got those placeables, I can then lay those out. There's a bunch of maths here. Essentially all it's doing is working out the X and Y coordinates for the top of my card so I know where to place them. And then here I'm doing the placement, just an absolute positioning with an X and Y coordinate. So let's put it in the animation. We're going to slide the cards from left to right. So what I'm doing here is I'm using an offset. So I'm using an offset like a percentage. So I'm doing the percentage change between the far left position and then that center point where that second card is. You can see in my little diagram there, offset 0 and offset 1. So to do this, I need to use a remember state for that offset, defaulting to 0, and then a launched effect. So this, if you haven't used it before, launched effect allows you to run a suspend function within the scope of the composable. This means if we destroy our composable, whatever we're running in this coroutine, because it acts like a coroutine, will get cancelled. It also means that when we pass in a different trigger, what you see there is the transition trigger, which essentially for my purposes is the position in the stack, it will reset that launch effect, reset that coroutine, and restart our animation. So in there, we're calling the animate API, and this is the target base. So we've got our initial value and our target value. We're just animating between those. I've also passed in an animation spec, which enables us to control how fast and how slow the animation is going, and if we want it to do anything fancy. I just have something basic for the moment. So next thing is we just change our calculations to include our offset. So just multiplying by this offset as a percentage here, and then placing that in the right spot. So that gives us our sliding cards. Looks pretty fun. Slide across quite nicely. So we want to flip the cards. That's the next step. Again, lots of code, but we're building on what we've got before. So what we want to do here is use our flip rotation. So this is just a value between 0 and 180, and it's going to enable us to flip the cards. If you have a look at the diagram, we have our 0 position for the card, then we have the 90 position, and then we have the 180. So that's how the card is going to flip across. So that's why we want to go between 0 and 180 for our rotation. We then place this into our launched effect. For this example, I want the flip to happen after the card is slid across. So I'm just placing them one after another so that once the offset animation completes, then the rotation animation will start. If you wanted these to happen at the same time, you can have 2 different coroutines that will run at the same time, and the card will actually flip as it translates, which is quite fun. Again, I'm using another animation spec here, it's just the same one as before. So how I'm doing this work is by using it in the modifier within the graphic layer, which just gives us that fine control over the distortion of the card, the flipping. So we're just using a rotation in the y-axis for this. You may also see the camera distance here. This is a fun thing to play around with. This enables you to view the animation at a different point. So instead of viewing it here, we're viewing it up here. What that enables you to do is as the card is flipping, you'll see the corners don't get cut off. If you didn't include the camera distance, the corners will get clipped off as the card moves beyond the area of the composable. It's a little hard to understand, but it's something worth playing around with. In your own example, try a few different values and see how that goes. I just found this value out by trial and error myself. Then I am using that, checking that value, and then changing which composable, which version of the card I'm showing, based on the position. So once we pass that 90%, that 90 degrees mark, I then change to show the back of the card. So we've got a card flipping. Is this looking good to everyone? Notice any problems? So we have a problem. As the card flips, you may, and changes, you may see that it kind of reverses. There's something weird going on. Look at this lightning bolt here. See it's flipping over? It's even more apparent if you have words and numbers there. What we need to do here, we need to flip the back of the card in reverse, so that when we're flipping it over, we actually end up with the reverse. It's a really complicated thing to work out, and I could not think of a good way of explaining it. But this shows a really good tip on working with animations, and my Bilue colleagues will have seen me do this quite a few times in the previous weeks, is use a paper prototype. So when I was working on this, and I should have included a photo of my paper prototypes, I had a whole bunch of little squares of paper with writing on the front and back, and then I was sitting there flipping them, moving them around, trying to work out how this animation was going to work and why I was seeing this reverse. And eventually I got to the point where I realised I sort of had to pre-flip in order to flip. It's a complicated thing. But the message to take is always grab some paper in front of you and try and move things around, use a whiteboard, something like that, just so you can visualise what you're trying to aim for. So we're done. Cards flip over, looking good. Are we done? You can't. I don't know if you can see it because our animation here is a little bit janky on the screen. But watch that green card as it flips over. Do you see something going on? So if you've been around Slack, you might have seen the Android channel. I was actually posting this question because I was struggling with this exact problem. And some people actually helped me, and it was great. So let's go through what the problem is. So in our normal no animation display, we have our initial state values, which are just set to 0. We read that state, and then we do the layout. All good, no animation. When we're adding some animation, we then have to calculate our animate value. So we take the state, we calculate our value, and we pass it to the next state, to the next frame. So in this way, we're really good. We keep going down the tree, we've always got our animate value, and we can keep reading the state and doing our layouts. But what happens when the user presses the flip button? We get our new data, our new transition trigger, and that comes in, and that changes our animate value. As I said before, it stops the coroutine, resets the animate back to the initial value, and we're good to start again. But of course, if you look at this graph, we've got our read state has still got the last value from the previous frame. So that's why we're getting the flash, because the animation is still over the other side. It needs to get reset back to the original side. It's a bit of a problem. How do we get around this? We need to reset the remember states when the data changes. So we reinitialize those so we know at the same point everything's initialized back to the starting position. So in our code, we can do this using our remember states and keying them to the transition trigger. This means that whenever that value changes, we will reset back to our initialization there, both at 0. So in our diagram, the user presses the flip button, our transition trigger changes, and we update both the read state and the animate value at the same time. We just discard that last animate value that we had previously. We don't want that anymore. So we're all good, and then our animate new calculation can go to the next frame like before. So finally, we have flipping cards with no weird frames, no reversing. It all looks good. We can even go with as many as we want. Because of the way I did this with a custom layout, no matter the size available, it will keep resizing my cards to fit wherever I want them. So in this case, it's a little janky on my screen here, but you can see that we can keep flipping, and on a real phone, the performance is not degraded, which is really cool. I could even go up to 2030 if I wanted to. We can even interrupt the animation and start again. So here I'm just clicking the button randomly, and the animation just stops, and we go back to the start, which is really helpful if you're making a game or something like that. If somebody's clicking heaps of times because they want to get through the animations really quickly, it just restarts. So we're not breaking anything, we're not breaking any data. It's purely visual, so it's all good. So that's the first example. So now second example, dialogue animations. So in a part of my app is I want to show this dialogue. And I want to show this, the user will do something like click the reshuffle stacks button, and then the dialogue will disappear. I'm going to use animated visibility for that. I could use my standard dialogue, it just appears and disappears. That's a bit boring. Let's make this nice and fun. we can make it expanding and contracting dialogue. So that we have this nice animation here, great for the user, they see this coming. You can do other fun things like bouncing around the screen and stuff like that. So, how do we want to do this? We have our standard dialogue component, like before, just a basic view model with some live data. We show our dialogue, and we do some stuff whenever the user presses the buttons. So then we have our dialogue composable. So we're just using our standard dialogue on dismiss. We call it dismiss request lambda. Then we have our button, and that will again call that reshuffle value and dismiss the dialogue. Pretty standard stuff. So if we want to put animations here, we want to make this reusable. Most apps, if they have one dialogue, they're probably going to have a lot of dialogues. So you want to make the same, you don't want to write the same code again, you don't want to copy and paste everything everywhere, you want to make it reusable. So we can do that with Jetpack Compose. What I've done here is create a dialogue that will take in our content and take in our dismiss request, and then we can just place our content inside the dialogue itself. So we don't have to have the dialogue setting up code in our actual content composable. We can reuse it. So here, we're just placing the content right inside. So now we want to define the animation. So for this, again, using a reusable function, you can plug and play different animations as you go, and that way, you can try out different things or have different behaviours depending on the user. What we have here is we're using the animated visibility API with a scale in and scale out transition, just to get that nice smooth animation there. And we have a specific animation time set as a constant. That way I can reuse that later, and you'll see how I reuse that. Again, you could include different animation specs to make it more fancy. Just note, this is an experiment. The scale in and scale out is an experimental API, so you will need this if you're going to use scale in and scale out. So now we need to trigger this animation, and we can do that via a coroutine. So just like before, we have an animation trigger. In this case, it's just a true-false value. And we have our launched effect, exactly the same as before, so we can run our suspend function and coroutines. This one is just keyed to a unit value, because we want this to run every time we show the dialogue. We don't need to change any data or things like that. You might see that there's a delay in here. So this is interesting. There was a blog post I was reading when I was coming up with this work, and they talked about the delay, and I'll share some links to that after. But the delay is so that the dialogue has time to build, because otherwise you might start the animation while the dialogue composable is still building. For my very simple dialogue, it's probably not necessary, it will build really quickly, but if you've got a whole bunch of other content in there, it will take some time. So you want to add a delay to make sure that you're only starting to open that dialogue when it's ready. It's something like 300 milliseconds, it's something quite small. And then once that delay has passed, we're setting our animation value to true. We then use that value in that animation scaling transition that we talked about before, and we're passing in our content. So it will only show that when that value is set to true. What this also means, really, is this dialogue kind of exists while that animation is happening. So the dialogue is still shown, it's just the content that's being animated out. So here we get our expanding dialogue. In this case, it's just expanding only. There's no contracting. This might be fine for most use cases, especially if you're transitioning to another screen. But if you're staying on the same screen, you might want that exit animation to show. So it's kind of an optional step, and it is a little bit more complicated, so if you don't need it, don't bother. So to get it contracting, what we're going to do here is have our dismiss animation. We need this as a suspend function to set our value to false. We then need time for the animation to run, again using our delay with that animation time constant. And then we dismiss the dialogue. So again, the dialogue is existing while we shrink the content. When the content is disappeared, we dismiss the dialogue, which means we dismiss that shadow background. So that's why, again, we have a delay in there. And again, this is a suspend function, so it will run inside a coroutine. Back to our dialogue code. We have our coroutine scope. We need this because we're not going to run this inside the launch effect, and we need to be able to run it inside a coroutine. A normal composable isn't able to run a coroutine, so we need the scope. And again, we want that scope to be scoped to the coroutine, to the composable, so that if we close the composable or destroy it, that coroutine will get stopped. So here we are, we're launching that coroutine with that scope, and we're calling our animation value here. This is on the dismiss request. So this will work for our normal back behavior dismiss. So you've got your dialog showing, you press the back button, and the dialog will dismiss. It works really well. We don't really have to change our original code. But if we want to dismiss the dialog from a button, it won't work. It's just going to be normal basic dismiss. So no animation makes us that. What we need to do next is dismiss via the button. So what we actually have here is we have our animated transition dialog. Our dismiss animation trigger exists within there. Then we have our content, and then we have our button. So if you think of it in terms of these concentric circles here. And what we want to do is from our button, call this dismiss animation trigger. Now, we can't really do that because the dialog content and the button don't know about what's above it. So how do we access that? We use a shared flow. Now, I've found shared flows hard to describe. I've been trying to get do this to my Bilue friends the last few days, trying to explain to them how one of these work. I ended up with this diagram, so hopefully this makes sense to those of you who know shared flow. But what we want to do with shared flow is we want to use the button to call our shared flow, emit a value to it, which will then be collected in our dismiss animation trigger. So we emit the value, and that goes back to be collected in our parent value, our parent composable. So we're using a helper function for this, animated transition dialog helper. It's a long name, I know. So that is what we want to do the emission to the shared flow. So we don't have to worry about that in our dialog content. We don't want to add an extra logic in there that we would then have to repeat for anything else we're sharing. So we need to take that shared flow and pass it into our helper so that we can use it there. Then we will request the dismiss, which will then collect the value back in dismiss animation trigger. And when this is collected, it allows us to do the dismiss. So how does this look in code? So what we have here is our shared flow. So we've constructed this in our coroutine. Again, it means it's scoped to this coroutine. This composable, again, it's scoped to this composable. We then make sure that our content of our dialog extends our helper so that it knows what to do. And then when we get to that content, we can pass in our helper constructed. This is our helper. So this takes in a coroutine scope and the dismiss shared flow, and then we'll emit the value to the flow whenever it's called. So then back in our content dialog, we can then make sure that we've got our dialog helper object and just need to invoke that to dismiss the dialog. Pretty simple. That's all the code we have here, and then here we are collecting that value from the shared flow. So we collect that latest value, and then we can call the dismiss and dismiss the dialog in the nice way. So we have an expanding and collapsing dialog. Pretty nice. So that's it at that example. Here's a few useful links. This recording will go up online, so you can grab these later if you want. But I found some really good Medium posts on this topic, and I recommend checking it out if you're trying out a few of these things. And I'm actually going to write my own blog post for these two examples, and they'll come out in the next few days for anybody who's interested. Thanks very much. Any questions? And if not, why do you keep saying coroutine is such impossible?
Interesting feedback. If you can go back to the dialogue one.
Yeah.
I just looked at the UI and thought
Coming up here.
one before, the one that doesn't change. Yeah. Before these it presses a button.
Yep.
You have this, right? And this hides one of the cards.
Yep.
So this has to decide before being, it's in the middle of the game?
It makes sense in terms of the game. They will reach the end of the stacks of cards and they need to reshuffle. They already know about it at that point.
Okay, well, still, I think that you could move this whole thing to the white part on the left here,
Oh,
where
absolutely,
there's a gap, and then that's like usually when you press on the bottom of the foot, right?
Yes.
Oh, okay. You don't press on the actual card.
The user actually doesn't care about what's behind it. But this app is still under development. I will actually launch it eventually. But yeah, it makes sense for the game, and that's halfway through. But thanks anyway.
And does it make sense to the user? Do they need to actually see the card slide and then flip, or could it happen at the same time?
It could happen at the same time. Just for my example, I decided to do it that way.
And is it more complicated to do both animations at the same time?
No, as I said before, you could just put those both into coroutines. They'd run as
okay. So all animations, as long as they're the same length, they'll look.
Yes, yeah. Okay. You just have to tweak them. I mean, they're both in the same animation set, so they'd be fine. Yeah. But for this, I just decided I wanted to break into two parts.
Yes, right.
Any other questions?
Yeah, so around the mutable state flow that you're passing to the child composable, you don't have like a lambda passing to the child composable and let the child composable call the lambda instead?
There was a reason I didn't do that. I'm trying to think. I've gone through a lot of iterations.
Yeah, is there like an animation that you're waiting for the mutable? Like once you subscribe to the mutable state flow, it collects the last state.
Yeah, possibly. I could try that too. Yeah, I'll have to give it a go. That's all I could say. I can't remember if I specifically tried that example, but I was following a blog post for this particular one and just modifying it from there. So that's what they chose to use. There's another question off the back.
Is there any suggestion about casting those animations?
What do you mean?
Much more like we can just kind of pass the composable with the UI cast, but how to kind of verify those kind of the translation is kind of actually expect.
Oh, for testing?
Yeah.
I haven't done much into Jetpack Compose testing yet. Jetpack Compose is still very new to me. But yeah, that is something I'm actually going to work on next. I haven't done any testing for these. But yeah, it'd be really interesting to make sure that they're still working correctly. If I get there, I'll do another talk. Do you have questions?
Yeah, when using the dialogue, is it something you experiment or is it something computer?
That's purely just an experimental value, just a constant. That's fine. I just worked out one that worked and went with that.
Apologies for the question, new here, but what is Jetpack Compose?
Jetpack Compose is a new declarative library, SDK framework. That's the word. For in replacement of the old Vue way of doing things with Android. So it's kind of the new kid on the block type thing.
It's specific to Android, is it?
Yeah.
Thank you.
And one more question, yeah.
Now that you can work with all those dimensions, would you say that it's easier and you put more animation in your application?
It was definitely easier than the Vue-based ones I was experimenting with showing. And I think it was because I had much more control and I could do things like coroutines, I could have used values, much more calculation than I could have just put into, like, for example, motion layout. I did have that same flash issue with the flipping cards that I did in the Jetpack Compose example. And thinking about it, I don't think there was a way of solving that in the motion layout version when I was trying that one in particular. I didn't spend a lot of time on it, but I don't think there's a way of solving that. So being able to access that state directly and reset it was super helpful in Jetpack Compose. So it's something I do want to focus on and get more in there. Cool.
Thank you. If anyone has any questions, we can reach out to Katie or Insa. Okay, we have one more round of applause for her.